points tomorrow. There are 4 proofs on there. Okay, 4 proofs. They will total 26 points out of the 51. Okay? The 4 proofs will total 26 points out of the 51 total. I am telling you what the 8-pointer is, the big one at the end. I'm asking you to prove the triangle is going to be isosceles. Okay, that is the one at the end of the test. All right. The other proofs I'm not going to discuss, but they will be 3 of them for 6 points. All right, let's keep talking. I am going to give you coordinates, number coordinates, not the variable ones we've been working on. Number coordinates of a triangle. You'll graph it, and you'll tell me if it's scalene, isosceles, or equilateral. How are you going to do that? So you've graphed 2, 2, 8, negative 6, 3, 4. You connect them. I'm asking you, is it scalene, isosceles, or equilateral? So what's your process, Sean? So basically use what formula? There you go, distance formula, yep. Or Pythag, whatever you prefer. And then how do you know it's going to be scalene? No sides equal, isosceles. 2, equilateral. All 3. Boom. All right, hello, Will.
So the distance formula is going to be on it?
I'm not going to give it to you. Okay. No, I'm never going to give you the distance formula because it's not given to you on the regions either. All right, so I'll never give that to you. Same thing with midpoint and slope. Congruence transformations, what are they? What are the 3 we talked about? Rigid motions. The 3 rigid motions. Rotation, reflection, translation. Yep. So I'm sure I'll give you 2 diagrams and say, okay, what did I do? Which rigid motion did I perform to get to this one, to this one? Finding the missing coordinates, that's what you guys did 2 days ago. Here's an isosceles triangle. I give you the variable coordinates. What's the missing one? All right, so that's number 6. And then you definitely know we're going over this right now. Here we go. You can just voice them out for me here. The 5 methods, what do you got for me? And everyone always forgets about it. Are you kidding me? HL only can occur in a right triangle. Hey, you do a proof tomorrow, and you're figuring out, oh, I got to do HL here. What's got to be in your proof? That it's a right triangle. Yes, that the 2 triangles are right triangles. Yes. Notice what's still not up here. Will? Side-side angle. Yeah, never going to be up here. Either is angle, angle, angle. Either is third angles theorem. Either is CP/CTC. These are the 5 you have. Deal with it. All right, sorry to come off a little strong there, but deal with it. Those are the 5 you have. You can't make up your own tomorrow. All right, anything you want to ask before we start the review problems about tomorrow? Okay, here we go. So go to your textbook right now. There's only a select few I wanted to do with you. Let's go to number 5 on page 310. Page 310, everybody, number 5. This is a true-false question. If it's true, just tell me it's true. If it's false, correct it, though. Okay, so again, we're on page 310, looking at number 5. Is this a true statement or a false statement? If it's false, be ready to correct it. The vertex angles of an isosceles triangle are congruent. And what that comes down to is, do you remember your vocabulary? So if you need to look back in your packet to the isosceles triangle day, do you know what the different parts are called? So I'll just say these sides are congruent. And if you get it wrong, you get it wrong. So it's true or false, the vertex angles of an isosceles triangle are congruent. Here we go. Let's start this off right with 1. Nice job. It is false. Now here comes the tougher part, Cameron, and that is correcting it. Because those congruent angles are not called vertex angles. They are not called vertex angles. Hey, everybody, the non-congruent angle is called the vertex angle. That's the vertex angle. Do you remember, Cameron, the name of the two congruent ones? Anybody want to help her out? Go ahead. Shout it out. Base angles are congruent. Okay, base angles. Okay, those are called the base angles. And while we're here, anybody remember what the congruent sides are called? You got two of them. Legs, yep. And anybody remember the non-congruent side? And remember, that doesn't mean bottom, that just means the non-congruent side. Where are those congruent base angles located? Across from the congruent sides, the legs, yes. Are we okay there? Just wanted to review a little isosceles triangle vocab. Go to number 27 now. Maybe on a different page. Just keep following the order of the numbers. Number 27. Pick this one in particular. I want to know if those two triangles are congruent. If they are, provide a method for me. Okay, 27. Are those two triangles congruent? If they are, identify one of the 5 postulates that says it's congruent. And again, I picked this one on purpose. Let's do this. 5. Are those two triangles congruent? If they are, give me a reason why.
Yeah.
By what method?
No. Wait. Yes. Because of reflected. Right? No.
If you're going to tell me two triangles are congruent, remember, we just wrote down 5 different ways to do it. I need one of those 5 from you if you're going to say yes.
Side, side.
Okay, so he thinks it's side, side, side.
But,
That's what I figured people would say.
it's not.
What's this side congruent to? This one. They're in the same triangle, not different ones. The only thing you guys have is reflexive. That's it. Do you see that? This side should be congruent to one of the sides in the other triangle, which it's not. Do we see that? This is not side, side, side. It's just side, which doesn't count. So yes, this is not possible. Guys, are we clear on that, why it's not side, side, side? The congruent sides are in the same triangle. They better be in different triangles for you to do side, side, side. We okay there? Just wanted to make sure we don't get tripped up on something like that tomorrow. What's next? Oh, proof 29. Here we go. And I'm just forewarning you, this proof is nothing like the ones you'll see tomorrow. But it's the only one in the textbook, so I had to go with it. That's why I gave you the tougher ones to do. And you guys know I always come off to you guys very honestly. If you can't handle this one, next 24 hours, you better be putting in some work. All right? These triangles I'm asking you to prove aren't even overlapping. All right, here we go. I gave you a pair of sides already. I started you guys off with a pair of sides. What else can you give me now? Okay, I started you off with a pair of sides. You see the two triangles you need to prove congruent. What else can you tell me is congruent in the diagram? Let's roll 19. Because they are? Okay, nice. And that gives me a pair of angles. Okay, got a pair of sides and just got a pair of angles. Need another pair up here. Remember, use your givens. There's one given we haven't even spoken about yet. 20.
I said that angle AB is congruent
Well, AB, let me mark it. Yep, ABE, congruent to
to CDE.
this one up here. CDE.
Yeah, but ABE.
Oh, ABE. Okay, that's a different ball game. So here, ABE and CDE, these two.
Yeah.
Okay, why?
Because parallel lines imply alternate interior.
Yep. Everyone see alternate interior up there? These two lines are, watch, ready? These two lines are parallel. Here's your transversal, inside and opposite. So it makes them alternate interior. So angle ABE, congruent to angle CDE. Yep. And that gave me another pair of angles. I think the triangles are ready to be proven congruent. Based on how we did it, as a class, what's the method of proving them congruent? 16?
Angle
Angle side. Yep. That side is not in between. Let me just see any show of hands. Anybody do it differently that maybe you didn't end up with angle side, you did angle side angle? Let's say you don't have the vertical angles in. Everyone see the other pair of alternate interior you could have had? So you could have had angle, side, angle instead if you took both pair of alternate interior and not the vertical. We all right? And again, that you're not going to see that. Sorry. All right. If you got your calcs with you, you may want to get that out because we're going that way here in a second. I think anyway. In a minute, yeah, we are. Go to number 40 though first, number 40. Okay, we'll need the calculator on the next problem, not this one. 40. You guys tell me you draw it out with the correct variable coordinates for 40. Isosceles triangle WXY, height of H, and a base of 2A. Okay, so number 40, draw me an isosceles triangle, correct variable coordinates. All right, let me know your 3 coordinates here. I'm assuming people started in the origin, but I don't know what letter you called that, so. All right, what are your 3 coordinates here? 7, let's help us out.
I had W was
Okay, so you got that 0, 0? Okay, so that must mean you put y over here as what coordinate?
2A0.
Okay, and then that must have meant what, x is up here. Amy, just give me your your x coordinate. A. Okay, real quickly, I don't know if some of you just overlooked this or maybe didn't see it. It says it's got to have a height of what? H, which means this height right here has to be H. So what's got to be my y coordinate? H, okay? I know we've said it before in class, when it's isosceles, you can call it anything you want. Not here, though, because it said it had to have a height of H. So it's got to go up to H on the y-axis. Everyone all right on that one? Okay, now I'll let you go. Page 315. Page 315. I'll give you, if you want to work with somebody in your group, that's fine. I'll give you guys about 2 minutes right now on number 11 to find X. Okay, number 11, about 2 minutes to find X on page 315. Correct answer for that one, 28. Number 19 on the same page. Ready to go? Okay, here we go. What do we end up getting? Hey, nobody. Just frozen in time. Good job. Amy, you were last. Calling some.
So I got angle 2 is 24.
Not bad, young one. Making up for your side angle comment.
Yep.
24 degrees. Where did he get 24? Maybe from his group, probably. But anyway, this triangle right here is what? Too harsh? Get over it. Isosceles, right? So across from the congruent sides are congruent. So that must have meant angle 1 was 66. How many degrees total in a triangle? 180 degrees. Or I could do it. Never. I'm going to go this way. 180 degrees. So I should have how much left over for angle 3? 48. What do you know about these two? Linear pairs are supplementary. So this would have been 132. Again, how many degrees in a triangle? 180. So this would have ended up being 24 as well. Okay. Questions? One last time. What is available to you till I let you go on your own? Back of your packet. There are textbook problems to try. Those answers for those questions are under the, maybe, probably not, of course, when I need it to work. They're under the homework folder for this week. Okay, it says unit test review answers. You have additional resources. Now, I mentioned one file I put on there that said tougher triangle proofs. Don't just automatically go to that. Try out the other one too that's got extra review because there's proofs in there too. If you guys just don't want to go right to the tougher ones, you want to try some more medium style ones, go to the other one I have, which is the extra review. There's proofs in there as well. All right? Questions about anything before I let you go on your own? Okay, we're doing something here. We got a lot of resources to start.